Thanks for the welcome, Shaka. As you said, hi everyone. I'm Cal Mitchell, and I'm the founder of SQLpipe, and that's a data engineering consultancy in London. And I've been building open source data tools since 2021. And I'm here to show a new data streaming tool that is designed to facilitate the building of AI training datasets. And there are a lot of data tools in the world, so you might ask yourself, why do we need another one? And my basic answer to that is that I believe AI is really hyped up right now, but it's underperforming the hype. And one of the main reasons for that is data infrastructure, not having clean data sets, etc. And most work in AI projects is actually data engineering. For the most part, we have the architectures that we need to run AI models. We're going to use a transformer model. That's what ChatGPT runs on. That's what Gemini runs on. That's what a lot of the recommendation algorithms that we all see in our social media feeds run on. And so most of that work is data engineering. To test this hypothesis, we conducted a meta-analysis of all of the studies that you see here on the right to see if AI models are actually getting any ROI. Are they making any money at all of these enterprises that are investing heavily in them? And so we broke it down by category, where we looked at academic reports, the best of which was one that we found called the Gen AI Divide from MIT. Some of you might have seen that study. It was pretty popular and came out recently. There are also a bunch of reports from consultants, people like KPMG, Accenture, these types. And then, of course, the AI vendors themselves want to publish reports that prove just how much money AI is making all of these enterprises. So we did a meta-analysis to see if, these AI projects are making any money at the enterprise level. And that meta-analysis is available on my website. It has all of these links as part of it. So if you'd like to see that, it is available for free on my website. There will be a link at the end of the presentation. So we reviewed all of these to see if AI is actually getting any ROI. Does anyone want to take a guess what we found? Not you, Richard, because he already knows the answer. Anyone want to give me a percent ROI that we came up with?
10%, 4%?
Good guesses. Very good guesses. It's kind of a trick question. It actually depends who you ask. If you ask the academics, it's around 5%. And frankly, I would trust the academics a lot more than I trust the AI vendors, for example. And to show that discrepancy, over here on the left is a screen grab from our meta-analysis showing some of the takeaways from the reports from the vendors, the AI vendors themselves. And of course, their incentive is to show really high ROI with fast payback periods. So Google Cloud found a 727% ROI over 3 years with an 8-month payback. Yeah, right. IBM finds 2/3 of AI leaders have more than 25% revenue growth uplifts. And Snowflake shows that 92% of AI projects have paid for themselves already. I personally am skeptical of those claims, but there is actually some merit to these reports, and we'll get into that. The reality check part of our meta-analysis was looking more at the consultants and what the academics have to say. So they researched and tried to find evidence of actual money being saved or made in CFO reports. And the best one we found was the MIT report, who found that 95% of organizations have no measurable profit and loss impact from their generative AI projects. Basically, they started these projects, they went nowhere, and that was the end of that. PCG, another report that we really liked, found that projects in the finance section of the finance department of companies found only an ROI of 10%, which was well below expectations. Here's a quick look at the executive summary from the MIT report. And the first line of the executive summary is, despite billions, literal billions in enterprise investment into Gen AI, the report found that 95% of organizations are getting zero return. Why is that? Why are we spending billions of dollars on this? Tons of smart people and well-performing teams are attempting to make this work, but it's not really happening. Why? Well, MIT mentions twice in its executive summary that most fail due to brittle workflows, lack of contextual learning, and AI learns from data, and misalignment with operations. Again, they say the core barrier to scaling is not infrastructure, it is learning. Now, AI learns from data, and both MIT and some of the vendors, for example, claim that data is the key chokehold. They think that these AI workflows or these AI agents need to learn and adapt to our workflow over time to improve and take edge cases into account. And that's not happening right now. So this is a slide from the Snowflake report on AI. And you can see just from the title, they have very different incentives from the MIT study. The name of the study is The Radical ROI of Gen AI. I doubt they meant the 5% ROI. Probably not. But they still say the same thing. They still say that these projects have the same challenges. Unstructured data is AI enemy number one, they claim. And they say one challenge stands out and merits discussion up front. The vast majority of data is unstructured, 80 to 90% by many estimates. And I also appreciate there was a little bit of humor. Only 8% say that none of these factors are a problem. Must be nice. These reports were really dry. That was the only joke I saw in any of them. So I hope I've convinced you that AI projects, for the most part, are overhyped and kind of burning money at this point, and that data, specifically getting good structured data for these tools to learn and adapt over time, is one of the key challenges keeping us from actually delivering value. So now let's talk about Remix, a data movement tool which is designed to build AI data sets as messages pass through it. Remix, which I love the logo, by the way. Very cool. Chicka chicka. Remix is a message queue that sits in the middle of all of your data systems and the rest of your tech stack. And it can be thought of as something like Kafka, but a lot lighter. And it also enforces messages into a certain format so that they can be interchanged between all of these systems. My priorities with building the system, number one, was ease of use in order to facilitate process change. I didn't want to make something that was really impressive and amazing technically, that was hard to use and couldn't be picked up quickly by teams, because then you're just going to end up in the same place where you have proof of concept projects that never go anywhere. I'm sure anyone who has worked in IT knows exactly what I'm talking about. And because this thing is designed to sit in the middle of all of your data systems for things to pass data between them, it can also tee the data into other systems as messages are passing through. So the first supported use case, because I started working on this with Stripe, the payments company, they wanted to be able to sync data between their customers' databases and their Stripe accounts. That's the first supported use case. But my idea was, while the data was coming through here, wouldn't it also be nice, while we had it in this nice clean format, to put it into something like Snowflake, or to put it in something like Hugging Face, in order to curate these AI datasets incrementally over time? And it was designed to be able to easily start now, curating these datasets clean from the start, as opposed to going back in time and fixing architectural issues to build one-time training datasets. To do this seamless data transfer and dataset building, we need to use something called a canonical data model. This is the Oxford Data Meetup. Anyone know what a canonical data model is? Come on, somebody. Okay. A canonical data model, we'll get to that slide. A canonical data model can be thinking of as like a lingua franca. Let's say Stripe, which speaks the language of JSON, APIs, and web requests, needs to talk to Postgres, which speaks the language of SQL. These are their native languages. And let's swap them out for German and French. They need some way to speak to each other, and that means they need a shared language in the middle. In this case, Remix can be thought of as English. They also speak English, they also speak English, and they meet in the middle. And you need this common format for these things to be able to interchange messages in a structured way. And the technology that I use to create those canonical data models is known as JSON schema. You guys have almost certainly seen JSON before, even if you're not a software developer. It looks like this. It's got curly brackets. But the important thing is that it's very readable for humans, and it's also very flexible. Here, this is defining a canonical data model for a product, which is exactly what Stripe wants their customers to be able to sync between their database and their Stripe account. And it has 4 fields. It has an ID, it has a Stripe ID, it has a name, and it has a price. So name and price, probably pretty self-explanatory. Price can be a number or nothing. Name has to be a string. And then ID is probably an auto-incrementing integer from the database, so 1, 2, 3, 4, etc. And then Stripe ID is a random string that Stripe assigns to any product that you put inside their platform. So this is all pretty simple. If you're not a developer, it might look kind of intimidating, but it's actually quite a simple structure. And it allows you to say, when something comes in from Stripe, does this incoming information fit in my canonical data model? And if it doesn't, I can discard it and throw an error. But if it does, then I can pass it along to these other things. So how does it actually work? I'm going to continue using the example of Stripe and Postgres because that is the first use case. Remix can get information in one of 2 ways. It can get information from Postgres using a system called change data capture, which is a way for databases to communicate changes to the data that's contained in them. Or it can get data from Stripe via webhooks. Stripe allows you to say, hey, if anything changes in my account, send me a message on this web address and I will handle it. So that's the 2 ways that information can get into Remix. It then looks at that data and makes sure that it can fit inside of our canonical data model. And if it does, it puts it into a queue for further processing so that we can rate limit it, etc. And assuming that it all looks good, once we get around to it, we can then update or insert a record into Postgres, or we can make an API call to update data in our Stripe account. So that's how Remix works. Do you guys have any questions about it up till this point? Go ahead, Shaka.
So basically, you're taking the survey type, whatever, turning it into a JSON and then set. So you have for each language, let's put a rotate scale into JSON.
Yeah.
And then from JSON to the other language.
That's right. It has to be translated twice. It has to be translated on the way in into JSON schema, and that JSON schema can then be reinterpreted and sent out to any number of systems. And that's the key, because it wouldn't be hard to sync data between 2 systems. You wouldn't need a central language for that. But if you also had Hugging Face here and Snowflake here and DuckDB here, then it's very hard to have German to Swahili and German to whatever. You want to go to one central language and then fan out from there.
So you need for each language, basically, a translation schema of some sort, some kind of method, right?
That's exactly right. And I won't showcase it here, but there is actually a link to a video at the end where I go further into detail. You do exactly what you just described in YAML.
Yeah.
I have a question.
Sure.
Why do we need to do these API calls and upset queries, given the fact that we're just monitoring what's happening into these 2 databases?
We are syncing data 2 ways between these 2 systems. Sorry if that wasn't clear. We're not just monitoring. We are syncing the data between those 2 systems.
Because the Postgres needs to talk with the...
That's right. In this particular use case, I can actually jump ahead a couple slides. So the reason that Remix exists in the first place, the reason that we need to sync data in 2 directions between those 2 systems, is because this is what Stripe currently recommends that their customers do to solve this use case. Looks kind of complicated, right? Like this is a complex software diagram with 1, 2, 3, 4, 5, 6 different systems. You have 2 Amazon Lambda functions that are going to require custom code, etc. You do have a queue. So this is like kind of difficult and is going to require continuous maintenance over time. And my idea was to consolidate those 6 tools into one, and then pitched it to the Stripe team that came up with this diagram. And they said, great, make it and we'll like give you the stage. And that's exactly what they did a few months ago. And that's how Remix was born.
A couple of questions. So going back to your charting there a moment ago.
This one?
Yeah, the one. So how do you stop, first thing is, how do you stop loops where a change over there gets synced across and then you sort of say, oh, there's been a change, let's sync it back again. Because that can then go on forever. And also, the JSON schema format is also used as for defining tool calls in large language models. I'm just wondering if that's a coincidence you're using that format because they're going to be LLM components.
Those are 2 excellent questions. And the first one, the loops, has an adorable name. It's called the dog chasing its tail problem. Love, one of my favorite named computer science problems. And that is actually a big challenge. You need to, I think it actually is a little bit easier from this chart to get the problem that Richard is talking about. If a product's information changes in your database, it's going to be propagated to Stripe through these systems. And Stripe doesn't really care where the change came from. It's going to then report that there was a change, and it's going to make our way back to the database. The database, again, doesn't care where the change came from. So it will report the change, and it'll go back to Stripe. And when I was beginning to develop Remix, this was exactly one of the key challenges that I needed to solve. Stripe actually, in particular, provides this thing in their API requests and webhooks called an item potency key. Not everyone does that, so I did need to make a generalizable thing. And basically what ends up happening is... It's an awesome question. Anytime Stripe sends us something having to do with a product, they're going to include a product ID. And that is this Stripe ID right here. And in the YAML files, God, you guys are asking great questions. In the YAML files that you have to define, you basically have to say where your primary keys are coming from. So it basically looks and says, hey, if this thing with this primary key changes, that's part of how it does the deduplication.
Right.
And the other question was, sorry, what was it?
So this structure, this format here is also the one used for defining tool usage in large language models, the structured outputs and stuff like that. So I'm just wondering.
I did not choose JSON schema because of that,
right.
But I chose JSON schema because it is by far the most popular way to define schemas.
Yeah.
So Go, which Remix is written in, has a JSON schema validator. Kafka, if you eventually wanted to move on to Kafka because it's more feature rich than Remix, Kafka supports JSON schema. So I just chose the thing that everyone else uses because that's kind of the point of Remix. It's supposed to be able to talk to everyone.
Mm-hmm.
So 2 awesome questions. Okay. Any other questions about this before I move on? Good. You guys are asking all the things that I wanted to say. So I started to allude to this, that when Stripe sends us anything about a product, it includes the Stripe ID. But actually, because Stripe is so large and they have so many customers, they have to support different prices for each object. For example, if you're selling something in England and you're selling the same thing in Europe, they need 2 different prices because they have different currencies. So Stripe, anytime you create a product, it also creates a price object, and they will send both of those to us in a webhook. Now, this isn't a talk about Stripe's particular use case, but it is useful to demonstrate the kind of challenges that you need to overcome to build these clean, structured AI datasets. So what's going to happen when Stripe sends us a price and a product? Because in our canonical data model, we have price as part of our product object, but Stripe models it in a price object. Well, as you can see, they're both colored red, and they both have the same values. We happen to know ahead of time that when Stripe sends us a price, the product key, which you would have to define in YAML, this relationship, is here, and it's going to be the same as this. So basically Remix says, hey, anytime I get a price object, I'm going to take the product key, and that's going to be my Stripe ID. Anytime Stripe sends me a product, I'm going to take the ID field, that's going to be my Stripe ID, and so forth. There are other challenges aside from this structure as well. For example, Stripe, instead of just calling the price of something the price, they call it unit amount. And unless you have the unbelievable foresight in your database to call the price of something unit amount, you're going to have to account for that. So this is the kind of challenge that Remix allows you to solve in one place, as opposed to in 6 different places. That's kind of a technical slide. We'll move off that. And we already talked a little bit about why Remix exists in the first place, but I'll just revisit the slide a little bit. Basically, there are lots of systems that Remix is replacing. You have to do deduplication. I'm literally reading the questions that you just asked, and field name changes. So yeah, we already talked about what I wanted to talk about with that slide. And let's bring it back to AI datasets. So those were some of the challenges that Remix is designed to overcome in that particular use case. And along the way, while syncing that information, while you have data in a nice, clean, structured way, you might as well build a clean data set for your AI use cases while you have it in one place. So Remix can help, for example, as I've just shown, building e-commerce recommendation engines. So while all of your order data and your product data is passing through, you could create these data sets that you can then use to build, recommended products, or you might also be interested in kind of AI models. You could also, if you are sending customer support messages back and forth, for sure, those messages could be passed through Remix and end up in an AI training data set. Or something as simple as manual data entry. If you're doing manual data entry in some sort of web form, you might as well send it through Remix on its way to its final destination so that you can build an AI training data set along the way. And I've been a little bit skeptical of AI in this presentation, and I am actually skeptical of the hype that it's currently going through. I don't think it's making a lot of money. I do think it has really great uses. I use ChatGPT all the time, and probably most people here do too as well. So I think AI is 2 things right now. It is totally overhyped and under-delivering. But it's also an unbelievable new technology that whenever a company does actually figure out how to use it well, then they really hit a home run. And we're all just figuring it out at this point. Remix is a new tool, and Postgres Stripe synchronization is just the start. It's just the first use case that I decided to support because I was working on it with Stripe. And because it's a new tool, we're actively seeking early adopters and are offering free support and possibly even some implementation help. And you can even influence the roadmap. So if you have a different database and a different system that you need to sync data between, that's totally something that you can request at this early time while we're still building it out. And now is the slide when I tell you to go to my website. Yeah. No, but all of the resources that I discussed are for free on my website. So you can read the meta-analysis that we did of all of the ROI reports that we read and what are the things holding everything back, etc. There is also a video where Stripe interviewed me on the technical details of Remix, if you actually want to know how it works at a nitty-gritty level. And there's also the Remix GitHub. And I would really appreciate a GitHub star. It actually really helps to get GitHub stars early. I think I'm only at like 10 or 11 right now. Definitely need to get those numbers up. I'll leave that up if you guys want to take a picture and open it up for questions. Yeah,
I have a question regarding, so if you go back a bit, one more. Okay, that's this one here. So it's a data entry and automation. Okay, so how is this system dealing with missing data?
Well, you can, in the JSON schema,
Input nulls.
you can put nulls or not. So it's actually pretty basic. Right now, it's just basically what is the field names and what types can they be. But JSON schema can actually be a lot more granular.
You can put probably some logic gates in the whole thing as well.
Yeah.
Why I'm saying that is that there is a bit of an issue when it comes to like these electronic health records. And one of the biggest issues is the fact that they are incredibly, how can I put it, they are basically Swiss cheese. You have, let's say, a patient comes to the doctor's visit and they are basically interviewed and they sort of all consult. It was a freak medical consult.
Yeah.
But not all data that comes into that form, if it's done on that day and in real time, is actually either recorded correctly or even recorded.
Yeah.
And the whole idea is that you have this kind of like stream of consciousness of everything that comes into like the database, and you basically keep tabs on things, and you can make it as some sort of even queryable form. So my point is, would this kind of technology be appropriate for like monitoring, let's say, electronic health records?
I would say there's going to be some dedicated front end talking to a database, and that's like the web application probably that is running this electronic health record system.
Yeah.
And Remix would not be appropriate to sit in between the front end of that system and the back end of that system.
Okay.
But what it could do is whenever that electronic record system makes a change in their core database, which is probably Postgres or MySQL or SQL Server, something like that, it can pick up on those changes right here. So you can publish change data capture in any major database, and it can then apply the JSON schema and say, hey, this is a valid record. We should include it in our training data set. Or it can be a bouncer. It can say, no, you can't come in the door because you didn't actually validate against the rules that we've defined.
So it can work as basically real-time quality control.
Yes.
Good. That helps.
Anybody else? All right. Cool. Thanks, everyone.